Hi guys, this PowerPoint is going to be our first set of notes for Unit 5 Geology, and this is all about Earth's interior. Okay, so the planet Earth has layers to it, much like an onion. There's two ways that scientists can divide these layers into groups. One way is based on, let me get my laser pointer thing here. One way is based on the composition. So if you're just looking at what the stuff is made out of, there's a layer called the crust, a layer called the mantle, and a layer called the core. The other way is by physical properties, so what the layers are like, not just what they're made out of. And when we do it this way, we can divide it into 5 pieces. There's the lithosphere, asthenosphere, lower mantle, outer core, and inner core. And there's a little star here because this is the classification scheme that we're going to be using in our science class this year. So the first layer on the outside, the outermost layer of the Earth, is called the lithosphere. And the lithosphere is like the cooled part of the Earth. So the inside of the Earth is really, really hot. The part on the outside is cooled, so we call this the crust or the lithosphere. This lithosphere is broken into pieces that we call plates that move around. Chunks of the lithosphere are about 100 kilometers thick, and it's made of mostly granite. So continental crust, like the continents and all of the land, is made out of granite, which is a type of rock. And then oceanic crust, so the seafloor, is made out of a type of rock called basalt. Next layer of the Earth that is underneath the lithosphere is called the asthenosphere. The asthenosphere is about 550 kilometers thick, so 5.5 times as thick as the lithosphere was. The plates of the lithosphere, how you can see in this picture over here, are floating on top of the material that makes up the asthenosphere. We use the term weak when we describe the asthenosphere because the rock is really close to its melting point. It's still solid, but it's hot enough that if you imagine like wax from a candle, when it's warm, it's kind of mushy and gooey, but it's not liquid. And that's kind of like what the rock is like in the asthenosphere. And then the asthenosphere is made of mainly a mineral called peridotite, which is actually kind of a bright green rock. So a lot of people think that the inside of the Earth is like red or orange or boiling hot magma or something like that, and it's not. It's mostly made of pretty warm green rock. Next layer after the asthenosphere is called the lower mantle. Sometimes people will call the asthenosphere the upper mantle, but its fancy science name is asthenosphere. So the lower mantle is 2,200 kilometers thick, so a lot thicker than either the lithosphere or the asthenosphere. The asthenosphere we called weak, and the lower mantle we call plastic, because in this sense plastic means solid but capable of flowing. So the rock in the mantle is solid. It's not magma boiling around. It's solid rock, but it's warm enough that very, very slowly over time, hotter portions will rise and then cool and then sink and then warm back up and rise again and cool and sink and form these really big convection currents. And those convection currents are what pull the plates along on top of them. So you can see in this diagram here, there's two convection cells next to each other moving in opposite directions. And this one to the right is pulling this plate to the right, and this one is pulling this plate to the left. So these two plates of the lithosphere are being pulled away from each other because of convection currents going on in the lower mantle. And again, like the asthenosphere, the lower mantle is made of that green mineral called peridotite. So the second to last layer of the Earth is called the outer core. The outer core is just about the same thickness as the lower mantle, 2,200 kilometers thick. It's made out of liquid iron and nickel alloy. So an alloy is just a mixture of different types of metals. And since most of the outer core and inner core are made of iron and nickel, we call it an iron nickel alloy. And it's liquid because it's really, really hot down here. So all of that iron and nickel is melted. And it's really important that we have the outer core of the Earth because the liquid iron flowing around in the outer core is what creates the magnetic field of the Earth. And the magnetic field, you can look in this diagram down here, deflects a lot of the radiation coming from the sun. Remember in the astronomy unit we talked about the solar wind is just the radiation coming off of the sun towards the Earth. The magnetic field does a good job of deflecting a lot of that radiation around the Earth so that it doesn't hit the surface. And then most of the rest of it gets absorbed by the ozone layer. So the outer core is our first line of defense against the sun, and then the ozone layer does the rest. Okay, here we are. The last layer, the most inside layer of the Earth is called the inner core. This is surrounded by the outer core. So the inner core is about 1,200 kilometers thick, not as thick as the lower mantle or the outer core. It's made out of the same stuff, the same iron-nickel alloy as the outer core, but the inner core is solid. And the inner core is even hotter than the outer core, so you're probably thinking, well, why is it not liquid too? Like, if it's even hotter, how come it's not hot enough to melt it? And that's because of the extremely high pressure that's found at the center of the Earth. When you increase the pressure on something, you raise its melting point, and so the pressure at the core of the Earth happens to be high enough that the central portion can't melt. It stays in its solid form. Okay, this last side is just an example, kind of what a slice of the Earth would look like, showing all of the different layers. So we have the lithosphere on the outside here. Continental lithosphere is typically a lot thicker than oceanic lithosphere. And then we have, this is called the MOHO boundary. It's just kind of a weird discontinuity between the solid lithosphere and the kind of gooey, weak asthenosphere. Then we've got the lower mantle here, the thickest portion, outer core that's in the liquid phase of the iron-nickel alloy. And then here, the most inside piece is called the inner core. And remember, that's solid because of really, really high pressure. Okay, thanks for watching.